Imagine you have access to, like, the most precise, mathematically sound instruction manual ever written.
Okay, sounds great so far.
Right. Every gear, every pulley, every circuit is defined with just exhaustive precision. But, and here's the catch, nowhere does this manual actually tell you how to put the first two pieces together.
Ah, yeah, that's a problem.
Exactly. You have a perfect inventory, but absolutely zero methodology.
And that right there is the ultimate paradox of diving into highly rigorous programming environments.
Yeah.
I mean, you are handed absolute mathematical certainty, right?
Yeah.
But on zero practical scaffolding.
Yeah.
You know what all the pieces are, but the cognitive leap required to orchestrate them, that is entirely on you.
And that paradox is really the driving force behind today's deep dive. We are unpacking a super fascinating developer diary from April 28th, 2026.
Yes, this is a great one.
It's written by a developer named Ang, and it's titled Notes on Haskell Programming, Part 121, Generating PDFs with Typst and Pandoc.
Which, for you listeners keeping track of Ang's previous projects, this is conceptually really similar to an older Python console app they built called TXT2Debook.
Right, TXT2 book. But our mission today isn't just, a standard code review. We're going to decode the real-world problem-solving process of a developer navigating some incredibly dense information.
We want to see how they structure their thoughts, really.
Exactly. How do you bridge that massive gap between abstract, strongly typed code and a tangible real-world result? In this case, a customized PDF document.
And what makes this source material so compelling to me is that Ang doesn't just hand us the finished, polished repository.
No, not at all.
We get the unvarnished friction of the learning process. And that friction actually starts immediately with the official documentation itself.
Yeah, before Ang can even begin to architect the document generator, they hit this massive wall trying to parse Haskell's API documentation.
It's famously dense.
Ang is actually incredibly blunt about this. They make a direct comparison to Elixir, noting that Elixir has a tool called Xdoc. And Ang considers Xdoc to be the absolute gold standard in tooling for documentation. But Haskell's docs, Ang describes them as just incredibly dense and, severely lacking in practical examples.
Well, the distinction here is really between reference material and learning material. And it's a trap that a lot of mature ecosystems fall into.
How so?
So Haskell's API docs are written to be highly technical, precise reference architectures. They're designed for developers who already understand the idioms of the language, and, well, they just need to check a type signature.
Ah, gotcha.
They are fundamentally not designed for someone trying to bootstrap a brand new mental model from scratch.
It's like trying to learn a complex programming stack from pure reference docs is basically like trying to learn conversational French by exclusively reading a dictionary.
Oh, that is a perfect analogy.
Right. Like you have all the raw vocabulary, you know the exact word for where and the exact word for library.
But you have absolutely no syntax.
Exactly. You don't know how to conjugate the verbs, so you can't actually ask anyone for directions. You possess all the data, but you lack the conversational flow.
Yeah, and that analogy perfectly captures the cognitive overload Ang is experiencing here. When information is presented without context or sequence, your brain has to work twice as hard just to infer the relationships between all those little components.
This sounds exhausting.
So, facing this wall of highly dense, context-free information, Ang makes a very pragmatic pivot. Rather than brute forcing the official docs, Ang relies on an AI to bridge the gap.
And I think this is a critical point. The way Ang uses the AI is super important. Ang doesn't just prompt the AI to, write a PDF generator in Haskell.
Right, because that wouldn't teach Ang anything at all.
Right. Instead, Ang tasks the AI to bootstrap a very small, isolated, but fully working code snippet. Ang essentially uses the AI to generate a functional baseline, a syntax sandbox, if you will.
It's a textbook execution of active learning. The AI provides the missing context, the conversational French sentence, to go back to your analogy. Once Ang has that working snippet rendering on the screen, well, they can start tweaking it line by line, breaking a variable here, changing a function there.
Just to see what happens.
Exactly. They watch how the compiler reacts. Ang is basically reverse engineering the dense API documentation by observing the live behavior of the system.
Which is such a smart way to learn. And that brings us to the actual architecture of the code. So once Ang uses that AI sandbox to figure out the conceptual flow, they start building the production module.
The XS2ebook.converter module.
That's the one. And the very first architectural decision happens right at line 1, which is organizing the workspace. So let's get into the anatomy of an import and this surprisingly philosophical debate over how to label your tools.
Right, because every software project requires bringing in external libraries, right?
Mm.
And in Haskell, you do this with the import command.
Yeah.
But Aang looks back at a specific like a comparison of their recent code changes and realizes they made a foundational mistake early on.
What did they do?
Aang had imported a crucial module called Text Pandoc, but they overlooked explicitly listing the exported functions. They essentially just pulled the entire library into the workspace.
And Aang admits this caused some serious confusion later in the development cycle. They didn't actually realize which functions were originating from TextPandoc versus, other libraries until a later commit forced them to untangle the whole mess.
And that painful untangling is what leads Aang to adopt this hybrid best practice for imports.
Okay, break that hybrid approach down for us.
Sure. So for types which are your data structures, like a map, Aang prefers to import them unqualified. You just write import data.map and then in parentheses, map.
Okay, so it keeps things clean.
Exactly. It keeps the type signatures super clean and readable. But for functions, the actual operations that manipulate that data, Aang insists on importing them qualified.
Which looks like what?
That looks like import qualified data.map as M. So whenever you want to search that map, you explicitly have to write M lookup.
Okay, I have to push back on this a bit on behalf of anyone listening who's actually building stuff.
Yeah, go ahead.
From an architectural standpoint, isn't explicitly qualifying every single function call incredibly tedious? Like if I'm heavily refactoring a code base and I need to move utility functions across 5 different modules, having hard-coded m. prefixes everywhere seems like it creates a ton of unnecessary friction.
It does.
So why not just dump all the tools on the table and let the compiler sort out what you need? Grab what you need, right?
Well, the friction you're talking about is entirely intentional. And it addresses the very real nightmare of namespace pollution.
Namespace pollution.
Yeah. If you dump every function from every library into your global namespace, you inevitably trigger a namespace clash.
Ah, I see.
So you have 3 different libraries that all export a function generically named build or extract. If you just type build, the compiler totally panics. Has no idea which one you mean.
It's like shouting, "Hey, you," in a crowded room.
Exactly. And Aang specifically notes this danger when interacting with Haskell's Prelude module, which automatically loads a massive amount of common tools into the namespace by default.
So that explicit M lookup prefix is really a traceability mechanism?
It is a trail of breadcrumbs. Your pushback about it being tedious to write is totally valid, but it ignores the life cycle of software. Code is read significantly more often than it is written.
That is a very fair point.
Aang's reflection here demonstrates a real maturity in development, optimizing for the reader, not the writer. By using explicit lists or qualified imports, Aang ensures that anyone reading the file can instantly trace a function's origin.
Including Aang themselves, like 6 months down the line.
Exactly, without having to search the entire project tree.
Okay, so with the namespace meticulously organized, Aang can actually start assembling the document. And to do this, Aang uses a builder pattern. They bring in specific tools from text.pandoc.builder, things like doc, header, para, and text.
Right.
Aang compares this process to writing HTML to construct a web page. You are essentially programmatically stacking blocks of content.
And this is there's a massive conceptual leap between stacking those abstract blocks in memory and actually generating a physical file.
Right, because the builder pattern just creates mathematical representation inside the computer's memory.
Yes. To turn that abstraction into a tangible PDF, Aang has to feed it to the Typst engine. And Typst isn't just a native Haskell function.
Oh, wait, really?
It's a completely separate external executable program running on the host system.
Ah, so getting an abstract functional language to talk to a messy external executable requires stepping outside the safe boundaries of the code. And in Haskell, you manage that interaction using an I/O monad.
Yes. And to fully grasp why this is so critical, you have to understand Haskell's absolute obsession with mathematical purity.
Okay, let's get into the weeds of mathematical purity.
Haskell fundamentally isolates pure logic from side effects. A pure function in Haskell is perfectly deterministic. If you give it the same input, it will always yield the exact same output, forever.
So it's completely predictable.
Completely. It doesn't check the system clock, it doesn't read from a database, and it certainly doesn't spin up a third-party typesetting engine like Typst.
Because the moment you interact with the physical operating system, you introduce chaos.
Absolute
Like the
chaos.
hard drive might be full, or the user might not have permission to write to that specific directory, or, the Typst binary might not even be installed.
Precisely. And if you don't aggressively manage that chaos, your predictable program just crashes unpredictably. The I/O monad acts as this sequencing mechanism to safely orchestrate those unpredictable side effects.
But Ang doesn't just use the generic I/O monad, do they? Ang executes the PDF generation inside a highly specialized environment called Pandoc.
Yep, Pandoc.
So, if a standard I/O monad is essentially like a general contractor managing the messy outside world of the file system, then Pando.io is like a highly specialized contractor who specifically speaks the Pandoc language.
I like that.
Right. Like it handles its unique internal states and is pre-configured to catch the specific errors that Pandoc or Typst might throw.
That is a brilliant analogy. The architecture here is actually very similar to how modern smartphone operating systems handle third-party applications.
Oh, how so?
Well, if you download a poorly optimized app on your smartphone and that app encounters some fatal error, it doesn't take down the entire phone.
Right, your phone doesn't just brick itself.
Exactly. It doesn't corrupt your contact list or disable your cellular antenna. The operating system runs that app inside an isolated sandbox.
Okay, I see where you're going with this.
If the app fails, the failure is contained entirely within that sandbox. The operating system simply reports the crash to you and gracefully closes the window.
And that is the exact mechanism of Pandoc.io. It's a secure sandbox for the typesetting engine.
Yes, it contains the blast radius.
By forcing the external Typst executable to run within Pandoc, Ang guarantees that even if the external PDF generation completely fails, say, I don't know, a font is missing, the failure is caught gracefully. It won't cause the entire Haskell application to unexpectedly terminate.
It really is a masterclass in containing external side effects.
But, managing a highly specialized environment like that usually comes with a massive tax.
You mean configuration boilerplate?
Exactly. You would assume Ang has to pass this massive object detailing every single parameter for the Typst engine, like margins, paper size, metadata, font weights, all of it.
It can be hundreds of lines of code.
But instead, Ang bypasses all of that tedious setup using one tiny, deceptively simple word. And that word is def. D-E-F.
And Ang actually goes out of their way to warn readers not to misinterpret this word.
Yeah, because if you are coming from languages like Python or Ruby or Elixir, def is a reserved keyword used to define a brand new function, right? It's a structural header.
Right. But in Haskell, specifically through a module called Data.Default def serves a completely different architectural purpose.
Yeah.
It is a polymorphic value that represents default settings.
Okay, so Ang uses it in this line of code. Write Typst def sample doc. So instead of writing out a massive configuration object, Ang just drops the word def.
Yeah.
But, and maybe I'm missing something here, how does the compiler actually know which set of defaults to grab? It isn't magic, right? There has to be some mechanical resolution happening under the hood.
It's not magic at all. It all comes down to the mechanics of Haskell's type inference combined with type classes.
Okay, walk us through that.
When the Haskell compiler evaluates that line of code, it looks at the type signature of the write Typst function. And the compiler sees that the first argument of write Typst absolutely must be a data type called writer options.
Okay, so the compiler knows there is a strict requirement for writer options in that specific slot.
Yes. Then it looks at the argument Ang actually provided, which is just the word def. Now, because def is polymorphic, the compiler essentially searches its internal registry.
Like looking up a part number.
Exactly. It's specifically looking for an instance of the default type class that matches writer options. And when it finds it, the compiler automatically injects the entire standard configuration record right into that slot during compilation.
Wow. So the compiler just evaluates the surrounding context, identifies the missing puzzle piece by its required shape, and automatically retrieves the correct default piece from the library.
That's it.
That's like sitting down at a restaurant and the waiter already knowing your standard order. It is incredibly elegant.
And the downstream benefit for the developer is just massive. It entirely eliminates boilerplate fatigue.
I can imagine.
Think about the alternative here. Ang would have to manually declare every single required field for the PDF writer, even the ones they have absolutely no intention of altering.
Which just clutters up the code. And Ang specifically highlights how powerful this is when you only need to change a single parameter.
Right, the template override.
Yeah. Aang gives a preview of a future commit involving document templates. Instead of rewriting the entire configuration object from scratch just to inject a template, Aang uses Haskell's record update syntax.
Which looks like let ops record writer template.
Just template. So they retrieve the full default configuration polymorphically and then solely override the specific delta.
The one single property that needs to change for this specific execution.
It keeps the codebase focused entirely on the unique logic of the application, rather than drowning the reader in hundreds of lines of standard configuration noise.
It's clean, it's efficient, and it leverages everything that makes Haskell powerful.
It really does. So let's zoom out a bit and look at the larger narrative we've unpacked today.
Let's do it.
We started with the harsh reality of navigating complex systems, having a mathematically precise manual that offers zero practical context.
Right, the dictionary without the grammar.
Exactly. Then we saw how Aang pragmatically leveraged AI not as an oracle to do the work for them, but to generate a functional sandbox for active, line-by-line learning.
A very smart approach.
We explored the architectural trade-offs of imports, realizing that explicitly qualifying namespaces is this deliberate friction designed to optimize code for future readers.
Traceability is key.
Then we tracked the conceptual journey from building an abstract, HTML-like tree in memory to safely bridging the gap to the physical operating system using the isolated containment field of Pandoc.
Containing that blast radius.
And finally, we broke down the mechanics of type inference, seeing how a simple polymorphic def allows the compiler to silently handle massive configuration structures, letting the developer focus strictly on the necessary overrides.
You know, every step of Aang's diary is really an exercise in managing friction. It's about translating abstract intent into a rigid compiler architecture and then safely translating that compiled architecture out into the messy, unpredictable physical world.
It really makes you reconsider the role of documentation in that entire pipeline. I mean, Aang explicitly noted that the extreme density of the API basically forced the use of AI to generate those working examples.
Which leaves us with a really critical, maybe even provocative question regarding the future of software engineering.
Oh, I like provocative questions. Let's hear it.
The traditional model relies on static, human-written reference manuals, right? But if an AI can instantly interpret a dense API and spin up the exact customized functional sandbox a developer needs to start experimenting, well, will static documentation eventually become entirely obsolete?
Oh, wow.
If you can dynamically generate the exact context you need for your specific project, why would you ever parse a generic manual again? The gold standard of tooling tomorrow might not be a better written document at all.
It might simply be a conversation with an AI.
Exactly, a conversational prompt.
That is wild to think about. If the blueprint is too complex to read, you don't need a thicker legend. You just need an engine that can instantly build a miniature working model of the extraction right in front of your eyes.
A sandbox on demand.
Definitely something to seriously mull over the next time you are trying to untangle a new piece of technology. Thank you for joining us on this deep dive. Keep questioning the architecture, keep building those sandboxes, and keep pushing the boundaries of what you can learn. We will catch you next time.